we're going to attempt to apply the exponent laws that you already know from grade 9 work, but we're going to try to do it with rational and integral components. So we're going to try to look at powers or bases that are not just numbers, nice numbers, integers. Okay, so these are the exponent laws. You would have known these, or you should know these. If you're multiplying and you add the exponents, if you're dividing, you subtract the powers. If you're if you're raising a power to a power, you're multiplying. And then we know that any power of 0 gives you an answer of 1, as long as the base isn't 0. And then if you have a times b or a divided by b to the n, then you just put the n on both terms. Okay, so those are the exponent laws. Those that you should be familiar with. What we're then going to do is take those exponent laws and try to use them in a bit of a different or more expanded fashion. So you've done everything with integrals. Okay. Now we want to talk about what happens when we add in fractions, fractional exponents, all right, or negative exponents. So based on what we've talked about, we should be able to then apply these to simplifying powers. So we're going to look at a few of them. So here's one here. We have 0.3 times 0.3. The first 0.3 is raised to the minus 3, and the second one is raised to the fifth. So if we refer back to our exponent laws, we're in this situation. We're multiplying, and we have a common base. So we're going to add the exponents. That's what we're going to do. So we're going to write this as 0.3 and then minus 3 plus 5. And then we're just going to add those together. So we get 0.3 squared. Okay, we just leave it like that. Or if it actually asks you to evaluate it, then you can just either use your calculator. I'll show you that. Okay, and you get 0.09. That's one way to do it. Or you can not use your calculator and know that 3 squared is 9, and if you have one decimal place and you square that, you end up with 2. So you end up with 0.09. Okay, so sometimes these are just going to say simplify, which means you leave it as an exponent. You don't have to go all the way down to actually getting a value. And sometimes they're going to say simplify and then evaluate. If they say that, then you need to get an answer. Okay, so let's just look at a few more examples. So here's one here. This can look pretty intimidating. Okay, but it's just a matter of following the rules. So the first rule says take these exponents, okay, and multiply them. We're looking back at this guy. Okay, we have something with a power and then raised to another power. So we're going to multiply those powers together. So if I do that first, that's going to give me minus 3 over 2 to the minus 8, and then times minus 3 over 2 to the 6th. Then what we're going to do is we're going to deal with this negative power. Okay, I have this negative power here. That means I flip the base. Okay, I take the reciprocal, it's called. So I'm going to write this as minus 2 over 3 to the 8th power, and then times minus 3 over 2 to the 6th power. All right, now, whenever you have an even power, it's going to negate the negative. The negative is going to go away. So anytime that number is even, the negative's gone. So I'm going to write this as 2 to the 8 over 3 to the 8, and then times 3 to the 6 over 2 to the 6. Okay, because, again, even power, the negative is gone. Then that looks bad, but what I'm going to do is I'm going to write this as 2 to the 8 over 2 to the 6, okay, and then 3 to the 6 over 3 to the 8. So what that allows me to do is just subtract the exponents. So I have 2 to the 8 minus 6 times 3 to the 6 minus 8. Again, looking back at our laws, I'm looking at this law now. I have a to the m divided by a to the n. All right, the bases are the same with the 2, and then the bases are the same with the 3. So I'm just going to subtract the powers. And that gives me 2 squared times 3 to the minus 2, okay? Which gives me 2 squared times, and again, negative power means I flip the base, so I get this. So I have 2 squared divided then by 3 squared, and that gives me 4 over 9. Here's another example, and again, I would encourage you to just jump back here for a second to go through this a couple of times because this is complicated in terms of the number of rules that we used. Okay, we used power to a power, then we used negative power, then we used division, and then we used negative power again, and then finally we evaluated. So it will take some time to sort of process this. Okay, but this one's a little bit simpler. We're going to, first of all, I'm going to notice that this power is negative. Okay, so what's going to happen is you're going to basically just flip the base so that whatever is, if it's in the denominator, it's now going to be in the numerator. Okay, that's sort of a quick shortcut in terms of doing that. Okay, technically what you're doing is you're doing this. You're doing 1 over 1.4 squared. Okay, and then you have the 1.4 cubed and the 1.4 to the fourth. And then if you divide by a fraction, you invert and multiply. So that means you're going to have 1.4 cubed times 1.4 to the fourth. And then times 1.4 squared over 1. Okay, which is how I arrived here. So mathematically, that's what I'm doing. But the sort of efficient way of dealing with it is if you have a negative power in the denominator, you just write the term in the numerator. And it works the same in the opposite direction. In other words, if I have a negative power in the numerator, I can just write it in the denominator. Okay? You can always go through this whole process. Okay? You can always do that, and it will always work. But the sort of quick way of doing all of that is it's just a matter of you're skipping a couple of steps. You're not showing all your steps. But you're going to end up with this. When I end up there, all I have to do is take 1.4 and I have to add these exponents together. So I'm going to get 3 plus 4 plus 2 because I'm multiplying. All right, so if you're multiplying, you add the powers together. So I get 1.4 to the 9th power. So that's my simplified answer. And then I can take my calculator and ask it to tell me what 1.4 to the 9th power is. And it's 20.66 approximately. So I'm just going to say approximately 20.66. So the exact answer is 1.4 to the 9th power. The sort of decimal answer or approximate answer is 20.66. All right. Here's another example. So what we're going to do is we're going to look at the x's first, and we're going to add their powers. So we're 3 plus 2 because we're multiplying them. Then we're going to look at the y values. We're going to add their powers. So I'm going to get y onto 2 plus and then minus 4. Okay. So that gives me x to the 5th and y to the minus 2. And then, again, what I'm saying in terms of what we just talked about is I can just write that then as x to the 5 divided by y squared because this is technically over 1. So if I have a negative power in my numerator, I just write it as a positive power in my denominator. So this is my final answer. Okay, if we look at another example, here's another one. This one, we're going to go 10 divided by 2 is 5. And then a, we're dividing, so we're going to subtract the exponents of 5 minus 2. And b, we're subtracting, so we're going to get 3 minus, but then minus 2. So we're going 3 minus minus 2. So that gives me 5a to the 3, because 5 minus 2 is 3. And then here we get 3 minus minus, which means we add. So we have 3 plus 2, which gives me 5. Okay, so that's my answer. And it's just a matter of being careful with those negatives. Okay, here's a few more examples. So I have a rational power, but it's got 3 terms inside, so this gets applied to each of them. So I'm going to multiply each of those powers by 1/3. So I'm going to have 8 to the 1/3, and then times a, and then 3 times 1/3, and then b, 6 times 1/3. You don't have to write this step necessarily. I'm just writing to show you what I'm doing. Now, 8 to the 1/3 means the cube root of 8. We talked about rational powers. 3 times 1/3 is just 1. And 6 times 1/3, or 6 divided by 3, is 2. And then the cube root of 8 is 2. So we get 2ab squared. That's how that simplifies. Okay. The next one we're going to try, we're going to add these powers, right? So we're going to get x to the 3 over 2 plus 1 over 2. And then times y, we're going to add those powers. So 2 plus minus 1. So we get x to the 4 over 2. And then times y to the 1. Okay, 4 over 2 is just 2. And then I don't have to write the 1 on the y, so I can just write this simplified as x squared over y. Okay. This one, we're going to, again, divide the numbers first. So 4 divided by 2 is 2. And then we're going to do a, and we're going to subtract the powers. So minus 2, because it's minus 2 here, minus that 2. And then b, we're going to go 2/3 minus 1/3. Okay, this power minus that one. So what we get is 2a to the minus 4 and then b to the 1/3, because 2/3, minus 1/3 is 1/3. And then again, with the negative power, what I'm going to do is I'm going to write it as a positive power, but in the denominator. So I'm going to write it like this. Okay, so I just basically take the numerator, the a minus 4 in the numerator, and flip it. I put it down in the denominator. Okay. And then our last example is this guy. So what we're going to do is the 1/2. We're going to take 100 divided by 4. I'm going to do the brackets first. So 100 divided by 4 is, 100 divided by 25. I'm telling you the answer. 100 divided by 25 is 4. Okay. And then we're going to have a. This is technically to the 1. So we're going to go 1 minus 4. And then times. And then you notice there's no b here. But I could sort of theoretically write that as b to the 0. So I'm going to go 0 minus 1/2. Okay. So I'm going to get 4a to the negative 3, b to the 1/2. Okay. And remember that this whole thing is raised to the 1/2. So what I'm going to then get is I'm going to have 4b to the 1/2, and then I'm going to take this negative power and put it down in the bottom, so a cubed, all raised to the 1/2. Okay. So that's going to give me then, I'm going to apply that 1/2 to each of the powers. So I'm going to have 1/2 times 1/2 here, and 3 times 1/2 down here. I'm just multiplying this in. So I'm basically just taking this 1/2 and putting it on the 4. I'm multiplying it by the b and by the a. So what I'm ending up with is 4 to the 1/2 is the square root of 4, so that's 2. b 1/2 times 1/2 is 1/4. And 3 times 1/2 is 3 over 2. So this is my final answer. Okay. So these can get a little complicated, but that's the idea behind applying the rules for exponents. It's kind of taking what you did in grade 9 and making it more complicated, but you can handle it because now you're in grade 10 and you have all of that grade 9 experience. All right. So hopefully that makes sense to you. You can try these questions, all right, from your textbook, and you can contact your teacher if you have issues with them.